Good morning, Ajay sir.
Morning.
Sir, before we start,
So, Asad, what are the different topics to cover? You are muted. You are muted.
sir, multi-group analysis.
Only.
Yeah. 9 to 11.
Okay. Should I start or wait for some time? Asad, whenever you say, I will start.
Sure, sir, sure. Very good morning to everyone. Actually, sir, the person actually who was supposed to introduce you, actually, she has some problem with the laptop. So I have to do her part actually. So a very good morning to everyone. Let's welcome actually Dr. Ajay Kumar Chauhan. If we talk about him, he has 20 years of experience in academics and industry. He has been a trainer actually, and then he has been training, say, lots of people. And then if we talk about the number of workshops actually, he has been taken. It is more than 500 workshops actually. So then in the last years, he has taken more than 500 workshops, which is related to say data science, related to softwares like say R, Python, Orange, SPSS, Stata, SAS, MS, etc. Uh, he has authored three books also related to financial analysis, say business research analytics, and financial risk management. So today, if we talk about the session, he's supposed to take a session on, say, multi-group analysis. And then I hope with the kind of experience he has been having in this area, we all the say participants of this say workshop is going to learn a lot. We from say the Department of Management and as well as ATAL AICTE say Training and Learning Academy. So we welcome you, sir, and then we expect say a fruitful session from you.
Okay. So, thank you. Okay. So, good morning to all of you. The topic on which I will speak is multi-group analysis, and I will use a smart PLS software to demonstrate the analysis. And so let me start the concept. So now I'm sharing my screen. Uh, Share the screen. The multi-group analysis is actually a start from a concept called heterogeneity. The heterogeneity. Now, the what is the meaning of the heterogeneity? So we have to understand what is the meaning of heterogeneity. Now there is a theory called UTED theory, and UTED theory say that there are some factors which are affecting the technology adoption. So this is called adoption, and this is facilitating conditions like then we have the perceived usefulness. It's like that, perceived ease of use. So this is the simple example I'm taking, and you have to just apply your common sense to answer me. The dependent variable is adoption. Just hold. Uh, Hi, yeah. Okay. So the facilitating condition, perceived usefulness, and perceived ease of use is having impact on the adoption. This is the simple relationship. Now, my question is that can we say this relationship is different for uh, different people? Can we say this relationship is different for different people? Yes or no? And the answer is yes.
Yes.
The all the variables have a significant effect on the adoption, but this impact is different for different people. And to identify that whether this relationship is different for different people, we take some demographics, like we take the gender, and after gender we can take the age. Then we take some other variables like experience. So we say that the relationship is different for different groups of people. This concept is known as expected heterogeneity or observed heterogeneity. We know that the relationship is different for different people. Like, for example, I'm showing you the model, UTET model. And if you see this picture, so let me open this picture in big. Yeah, you can see that the performance expectancy, effort expectancy, social influence, and facilitating condition is having significant effect on behavioral intention to adopt. And these relationships are different for different gender, different age, different experience, and voluntary to use. So this is called expected heterogeneity. Means you are expecting that this relationship is different for male and female. These relationships are different for young people, middle people, old people. So in this way, we explain the concept of expected heterogeneity. So I'm saying here, this is called what is expected heterogeneity. Means the difference can be studied by taking some demographic profiles. Okay. Now this is only one thing, one aspect. There is another case that is called unexpected heterogeneity. So the second case is known as unexpected heterogeneity. Heterogeneity. Heterogeneity means different groups, different groups. So now there is another case of unexpected heterogeneity. And what is the meaning of unexpected heterogeneity? That in your segmentation, suppose this is your customer, and we are studying the shopping behavior. Let's say, so we are studying the shopping behavior of the customers, and all the theory, like theory of planned behavior, is explaining the shopping behavior. But from my experience, I can say that there is a category who is quality conscious, and there is another category who is price conscious, right? This is quality conscious and price conscious. And the problem is that we are not dividing the customer into this is this is of the behavior of the shopping behavior. So this is from covering. So beta and the impact is the analysis called MGA, and the reliability and validity can be also examined by algorithm. We have technique like PLS algo. So we can apply the MGA in two ways: analyzing the beta and analyzing the reliability and analyzing the validity. So this concept is the third concept is known as invariance. Variance. So now let's do it. All I want to know whether you are getting the points or not, because whatever I am teaching you is not available in the books. I'm only taking the all examples from the any query so far. So
Sir,
no question. Yeah.
sir, may I interrupt?
Yes, please, because
Sir,
interaction is very important.
Ajay sir, actually, because we are that we can use not picking up them a lot.
Yeah, let's so they're doing it.
Sir, oh, that would be the next one, sir. That would be the next one.
Next one. Okay, fine. Okay, so I am covering all the three aspects. The different the all I am going to PLS part. Here, PLS is looking like PLS. The software will open. Yeah. Now I'm going to show you the multi-group analysis. So I have to go for a new project, and here the let's say MGA analysis, and I am putting zeros because I want this to be here in the top, because I am working on different projects. So there is a long list of the projects. and many projects. So I am putting 0 because I want to launch this project here. When I created this new project, the software is requiring moderation uh, as you can see, place age, but age. If I the double the variables are age is having three variables categories. Gender is having two categories: HASIPE. Standard expect the performance expectancy. Performance expectancy. Then I have this social influence. I mean social influence. Social influence. And so you can see the steps of making the model. Then HA is habit and BI is behavioral intent. And there's a UB and UB is there. So let me see. So BI is my, where is BI? PI. BI is behavioral. So these variables have a behavioral intention. H is the habits. And UB, let me check. Here they are beta. Okay. If you click on the in the this is called data. So when you click on the data, so the software is showing you there are 354 observations and generate data groups. You can click on this part, generate data groups. So if I click on the generate data groups, uh, I want to see the gender is one of the group. So where is the gender? Gender is this. So this is the gender and okay. So there are three groups in the gender. So why it is three groups? Let me check. And okay. Okay, no, there are two groups only. So in 152, 142 candidates. In two, there are 211 candidates. And let me edit them. Gender one is actually the male candidate. Okay. And gender 2 is actually male candidates. So now groups, male, female. We are created the two groups. Technique multi-group analysis. So you can see the technique called multi-group analysis. Multi-group analysis. So now I click on the multi-group analysis. So which variables you want to compare? I want to compare male with and anything else? No. So you just read three lines. The selected groups will be accessed for significant differences on the parameter estimates, outer weights, outer loading, and the path coefficient. All data group selected under group A will be compared against all data group B. Now go start calculating. Study because studying the result is quite technical. Taking all the results clear it. I have each and every file. So that I can copy result here. Okay. Let's open a new file. So this is a blank multi-group analysis. Because there are so many tests which comes like parametric test, MGA test, test, different test actually. So first of all, I am taking the bootstrap test. All the values you can copy by clicking Excel format and paste on the here. So now the this is my beta 1. I am writing like this: beta 2, beta 3, and beta 4. So the uh, we can also insert here. This is my dependent, and this is my independent. Because when you report in the paper, you have to report like this. So in this case, the dependent is usage behavior. Yeah. And behavioral intention is my independent variable. In this case, the behavioral intention is my dependent variable and the is my independent variable. Actually, in all these cases, the dependent variable is the same. So let me take this from here. And the independent variable is different in both the cases. Similarly, I put so this is the dependent and independent variable, and I'm taking also the model. Let me copy this model and paste here so that we so you can see here. Okay. Now we are comparing what? We are comparing the path coefficient. So this is the path coefficient for the female, and this is the path coefficient for the male. So we should write the beta of females, and here we write the beta of males. And after that, we are not requiring this, so I'm deleting it. And this is the t statistic of female, this is the t value of male, this is the p value of female, and p value of male. So we have to put like this. Now I'm taking the t value, and t value of female is this. All the values are more than 1.96, so you can put double star. So double star means they are significant. So when I put double star, it means they are significant. Now, so what is the means of this line? So the this table, this part, which is the female part, the result is that there is a significant effect. There is a significant effect of all the independent variables on the dependent variables in case of females, because this is the beta and this is the t value. Similarly, we will go for the males. Let me put here. So this is the t value of male, and we design them in different color. And because all the t value are also greater than 1.96, so we can say all of them are significant. And let's say, so all these value we don't require. Okay, now what is the conclusion? So because whenever you report in, you have to report this table. Okay, the social influence, let's say, the social influence have a significant effect on behavioral intent. In female, the beta is 0.239, and in male, the beta is 0.347. So beta in female is only 239 and beta in male is 347. So we can see that the more impact is there in on male and less impact is coming on female. Now, if you see this line, how performance expectancy, this line, how performance expectancy is impacting the behavioral intention. The beta of female is 0.323 and it is significant, and the beta of male is only 0.229 and it is also significant. So it means more impact we found in case of females and less impact we found on males. In case of habit to behavioral intention, I think both are same. And in behavioral intention to usage, the male beta is higher than female beta. So in this way, we are comparing the beta of two groups, male and female. Now the question is that, are these beta different? Are these beta different? Because here the null hypothesis is that, let me, okay. So in this is a Google Meet we can here. So now the null hypothesis is that the is same or different. Now suppose this 2.239 and 0.347, the question is that are they same, are they different? Are they same, are they different? So we have to find out the answer of this. Now I am writing here this is the hypothesis testing. So what we are testing, whether the beta of male and beta of female are same. So hypothesis testing result we can find from also in the result. Multi-group analysis, go to parameter test, and you can take all these values, or this value parametric test is I think better. So we can take the Excel format and paste all these values here. Okay, let's paste here so that we can take our desired value. So we require only this, cut and this, paste. Now what we are comparing, we are comparing whether the male and females are different in the impact or not. Now if you see 0.748 minus 0.716, the difference is this. This is basically the difference. So the beta of male minus beta of female is 0.032. So male is having more impact by this much. Similarly, beta of female 463 minus 478 is equal to minus 415. 0.229 minus 0.323 is minus 0.094. 0.347 minus 239 is equal to 0.108. So this is the difference in the beta. This value indicate you the difference in the beta, and the t value, this is t value. This t value indicate whether this difference is significant or not. Whether this difference is significant or not. So this is the case of independent sample two t test. Two group MGA, because we are comparing only the females and the males with respect to beta. So if you show in the table is coming like this, and now you can last put remark. So remark means what is the conclusion? So I am writing the conclusion in one like no difference is found between males and females with respect to the beta for the structural model. And let's wrap it. So this is the conclusion, that there is no difference found between male and female with respect to the beta in the structural model. So what I show you is just the MGA in case of two groups. The MGA in case of two groups. So this chart, this table, and this conclusion will go to the paper and explain the results. So now I'm going to the three group analysis. So three group analysis is more complicated. Is in fact. So now let's do the three group MGA. We don't have four group MGA. We have only two groups. Three group MGA and two group MGA. So this is now MGA. We are taking this part same, and rest of the values we will take from the table. So now we are moving to the three group MGA. Because model is same, so model is same for three group MGA also. So complete model you can see. Now values I require, and it is too complicated to report the three group MGA. Okay, so first of all, go to list, delete this. now in MGA, first of all, you have to click on the data. In data, delete the old groups, and now click on the generate data groups. And here the age group, the group is age. The group is age, and the variable age is here. Age you can see here in the first, and click OK. Now we are having three groups, one, two, three. The first group is, you have to name it. The first group is young people. The group number two is middle age. Okay. And the group number three is old. So now in three groups, middle, old age, young, middle, and old. And the number is here. So now, although we require this to be more than 30, but let's see. So for then each group must have 30 observations. Okay. After defining this group, the model, and when you go to the model, go to the calculate, go to MGA. Now we are the so we have to click formula first, and all the three. So we are comparing the software will make different pairs. Will compare all the groups, including full data set. Okay, now the table is ready. And okay, you have to okay. The sheet. So arrangement is quite technical. So that's why I am doing in the Excel file. Okay. Oh, so let's do here. So we don't require path coefficient. This is the path coefficient of, let's see. Yeah, this is the path coefficient of middle. This is the path coefficient of old. So we have to arrange these values like this is the beta of young, t value. This is the beta of middle. You have to arrange like this, and t value. And this is of old, t value. So first of all, we want these values so that we can compare the values. Okay, so this I don't require. Let delete it. Now this is the beta of the middle. I'm taking this, all these were in the beta middle. So we can remove this. Now this is the okay path coefficient of the old. These are the path coefficient. The old, beta, young. Okay, so they are no problem. Just cut and paste here. This is of the old, and so this is the t value of the young. T value of the young, T value of the young, and this is the path coefficient of the middle. So the table is quite lengthy. The beta of the young, I think this is the beta of the young. So like this, beta of the young, T value, beta of the middle, T value, beta of the old, T value. So these are, this is the path coefficient of the old, and this is the path coefficient of the young. So let's delete them. Delete of the middle, T value of. So I will take only 1 minute to arrange all these things, because when you compare between so it is make this table to show the or to compare. Okay. So I need the T value of the old, T value of the old. These values I also not require. Delete. So T value of the young, T value of the old. So I take all these values here, and T of the mid. Now I think I've yeah. So we can delete all these values not required. So for now we can compare. So we can compare the beta of everything. So let's compare behavioral intention on the usage behavior. The value of the for middle it is 0.733, and old it is very high. Now you can see the old is very high. So this line here. So impact on the behavioral intention on the usage behavior is the highest in old, and so both of them are equal. In case of social influence and behavioral intention, the beta in young is 0.26, 0.26, and 0.23. Now it is the least. Here you can see the least. So least can show by this, and we can show by this. So similarly, and in case of the habit on the behavioral intention, 489, 499, and 4. So this is the highest. And the both are actually the same. Both are actually the same. Similarly, in performance expectancy on behavioral intention, this is low 2728, 2728. I think. So what is the conclusion we are drawing here? The in case of behavioral intention and habit, the old people are having the maximum impact. However, in case of performance expectancy and social influence, the beta of the old is the lowest. So this is the first conclusion we can draw from the results. Now the question is that are these beta different, or are the beta same? So this is another question. Can we say this higher side or the lower side are significantly different, or they are actually same? So for that we have to do comparison, because there are three groups. The next middle, young versus old. So there are three comparisons. So that's why I have to take the table from here. So I'm going to the parametric. First of all, copy these values from here, and let me paste this side, so that whatever I need, okay, let me paste here so that I can take whatever from here. This is the middle minus young, and this is the old minus young. So you can see that there are three comparisons. There are three comparisons, and then we are having three t values: middle versus old, middle versus young. This is old versus young. P value, any p value is not found to be significant, not significant. So some significance. So you can say the old and young are different. Old and young are found to be different. So these two values are found to be higher in case of old as compared to the young. So this is the conclusion you can draw. In all other cases, you can see the p-value is not found to be significant. Only in these two cases they are near to the significant. So in this case, so we have to report all these values here, but that will take time. I'm not doing that. I hope it is clear how to do MG analysis in this PLS. So similarly, I'm also showing you the analysis. For example, let me delete here, and this is MGA, my model, and I have how many groups? Three groups. Okay, so let me try the consistent PLS algorithm. So consistent multi-group analysis. You can see that consistent multi-group analysis, I am doing it. The start calculation. So you can see that the software is doing this multi-group analysis. And so you have PLS MGA, parametric test, then bootstrapping. And so somehow it is similar to the previous one. The patients and so the values you can see, which you can see here, 0.028, 0.013, 0.09. In these three positions, the difference is found to be significant, middle versus old. Now, this is according to the simple consistent PLS, not bootstrapping method. This is simple PLS consistent. If you found green, so it indicates that these groups are significantly different in terms of path coefficient. So this is middle, minor, and this value is replicated this one. This value is replicated this one. Similarly, the third value is replicated. Okay, actually there are three p values you can see, and if you maximize it, you can see what we are comparing. So here we are comparing the middle versus old. So middle versus old. So this is found to be significant. Right. So this is simply known as the multi-group analysis in case of PLS. Now let me try. And yeah, and click on the middle, old, and young, and start calculating. So you will get the result here, right? So now I'm comparing the reliability and the validity and the discount validity in all the three groups. So this is noise. So let me open this or a new sheet. So now I have what? the multi group analysis for reliability, uh, vergent validity, the discriminant validity. So this type of report show, like first is the reliability, and measured by Cronbach. And we are having two groups. One is the second is middle, the third is old. Right, so we will denote the Cronbach alpha here, and this is the. So let's do the young first. See, so let takes Excel format and okay, let's paste in this case by alpha. In case of young, okay, let me take these two value lower side. Okay, now all the Cronbach alpha you can see 0.7 done. So we can put the here. Um, let take it here, and now the work is done. So I am deleting this part because this I require later on. Insert. So I put here satisfied. So the reliability of the young people are satisfied. Similarly, you have to go for the middle and Excel format, and we paste. This is middle results. Paste here. These values now I'm copy and paste special transpose like this. And so all these values are more than 0.7. So it is also satisfied. And similarly, we can do for the old. Now, this is the all the values are for the old. So the first condition is satisfied. That Cronbach alpha of all the groups are satisfied. So we can take all the values, copy, paste special, transpose, and this. Now this is also satisfied. So we can say what is the final remark comes here. So we will write there exist group invariance with respect to the reliability, internal consistency, reliability, internal consistency, reliability. So in this way, we prove that the data is in invariance with respect to these three groups. So this is called reliability multiple group analysis, MGA for reliability. Similarly, you can also proceed this exercise for convergent validity and discriminant validity. So I'm not doing in Excel form. I hope it is clear from this table that how we can report the invariance test for multi-group analysis. The same table you have to prepare for composite reliability, for average variance expected. So for example, I already have these two values. Let me do it. This is the composite reliability, and I can just paste special transpose. So this is for young people, and composite liability for the old, for the middle is this. So we can just pay special transpose. Now we have to check whether all these values are more than zero point 0.7 or not. So I think all the values are more than zero point 0.7. Similarly, for the old, we have to check whether all these values are more than 0.7. Convergent validity also exists with respect to, this is middle and this is old. So there exists group invariance with respect to composite liability. So this is the conclusion. Similarly, you can do for the average variance expected. And let's see. In this case, the average variance expected is problem in here. In this case, the average variance expected is problematic in this case, and the average variance expected is problematic. Okay, in for middle group there is no problem, and the old group even there is no problem. So uh, it means the group invariance exists between these two. Sorry, do not exist. Group invariance do not exist between the young, middle, old, and age. So we can also compare from here. If you click on the complete, this is the complete result. And if you click on the middle, fine, everything is fine. In case of young, we are having the problem in case of average variance expected. So invariance is not satisfied. Similarly, we can go for discriminant validity. In discriminant validity, you can see that this value is less than this. So discriminant validity, okay, you can report heterotrait, monotrait. For young, the discriminant validity don't exist. For middle, don't exist. For old, okay, there is a problem. So there is a problem in the old too much. So there is a problem of the discriminant validity in all the three, right? And if we go to the in complete wise, we have one problem in the habit. So this is called discriminant validity group invariance. Similarly, you can also go for model fit. Model fit in case of middle, satisfied. In case of old, satisfied, nearly satisfied, because SRMR should be less than 0.05. Similarly, for the young, it is also quite satisfied, and for the complete, it is also satisfied. So this is known as the group invariance, multiple group analysis with respect to invariance test in reliability, validity, and okay. So I have shown you the three aspect. So I am showing you one more thing. So whatever I have shown you in this case, this is called observed heterogeneity. Observed heterogeneity. So this is called multi-group analysis, observed heterogeneity. So sometimes we are not clear whether the group can be converted into different unknown clusters or not. So how to capture the unobserved multi-group analysis? So that I am showing you. Now we can do one thing. We can go to the calculate. We can go for Fimix segmentation. And suppose I am believing in two clusters. Suppose I am believing in two clusters. So how many segment you require? The answer is two. I'm going for two. I can go for 3, 4, 5 also, but let's start with this two. So if you go to the start calculation, the software will make two clusters. So software is making the clusters on the basis of the results. So first of all, okay. Okay, actually we did this mistake, so I have to repeat it because I have to apply this for the complete data set, not for the, no, actually I have to delete it because I have to run Fmix on all, right? So we have to apply for full data, not the groups. So I'm do it again. So software is running only on the full data set, not only different groups. Here, I believe that the segmentation is on the full data. Segmentation is not in the different groups. So now if I go for segment assignment, discrete segment assignment, so you can see that I got the segmentation. Okay, let me copy here Excel format, and I have to paste the segment. This is segment number one, and somebody may come in segment number two, segment number two, segment number two. So these are the unobserved clusters, unobserved clusters. So I have to make the segments. So let me go to the uh, data, because I have to define where is my data, smart PLS final data set. This is the data set moderation. Okay, now I put this data set here, I save. So this is the segment, so I put here segment, and the case ID I delete it, not required, paste it, save it. Okay, now I am importing the new file. So import data file, I import one new file, the moderation again. Okay, the software is saying that the file already exists. Okay, no problem. So we can remove this and import the new data file. Yeah. So now you can see that I have the new data file, and in this new data file, we are having a variable called segment. So let me go to the model. And the last variable you can see, this segment. So this segment is representing the unobserved heterogeneity. Now, unobserved multi-group analysis. So let me go to the data first and generate data groups. And this, now it is called segment. And the variable I have to find out here, the segment, two unique values. Okay. Now the problem is that in second segment there are only 15 people, and in first segment there are only 339. So a huge difference I found. Okay, so I edit it. This is called big segment, big segment, and this is known as the uh, small segment, small segment. And okay, so now I want to compare them, and let's do comparison in case of the path analysis. So I go to the model again. So model, calculate the MGA, and I'm comparing the small segment with the big segment, and doing the calculation. Okay, so I this parametric test is showing you that there is a difference between two segments in this aspect, and there's a huge difference in these three. The impact of habit, the impact of performance expectancy, the impact of social influence, these three impacts are not significant. So these three impacts are not significant, but this impact is found to be significant. So this is something which is different in case of uh, path or in case of beta. And if I go to the confidence bootstrapping, so let me see. Okay, you can see that this difference is also there. So p-value in case of big is significant. The p-value in case of insignificant, this is also important. This is also important table. Now let remove this. Okay, t value we require definitely. So this is the path coefficient of big. This is the path coefficient of small. This I don't require. This is the path coefficient t value of big, t value of small, and beta for big and beta for small. Now you can see that in case of behavioral intention to usage behavior, the first one, the big beta is 0.843 and this beta is negative. Okay. So first big group have if they have behavioral intention, they will go for usage. And the second group, if they have behavioral intention, they will not go for usage. They will not go for usage. So there is an entirely different aspect we find in multi-group analysis, and this heterogeneity is actually known as also known as the unobserved multi-group analysis. Okay, so surprise, and if we compare these two results, the beta is found to be 0.1 and beta is found to be 0.26. So there's a huge difference. So big group is showing you positive impact of habit on the behavioral intention. However, in this case, the small group is showing you high beta. You can see that in two cases, this is high beta. So the performance expectancy have a behavioral impact on the behavioral intention very high in the small group. This is also high in the small group, and this is lower in case of these two beta set. So this is whatever I have shown you here is known as the unobserved heterogeneity multi-group analysis. And similarly, we can also do this in case of invariance test. Let me show you that. If you go to the model, PLS, and now we are comparing the big and small. So we can see how they are different with respect to reliability and validity. Even in case of R square, the complete R square is very high, 66% in case of usage behavior, and the 98% in case of behavioral intention. If I click on the big, the answer is very good, 92%. But if we go to the small, so we can say the so we are getting some unexpected result. R square should not be more than 1. So it means they are creating problem in the data set. So they are creating problem in the data set. Similarly, if you go to the construct liability, for a small set, they are it is high. For big group, okay, so it is not satisfied in both the groups. And similarly, if you go to the decision validity ratio, and for big, for a small, there is a lot of problem in case of a small group. So this small group is creating problem in the data set. So you can do one thing, you can remove this segment, because there is a lot of problem coming from this group. In we can do in MGA, in PLS. Now I'm showing you the another case. If I import the data in SPSS, I can do some segmentation also. So this is data set. I am importing this data set in as SPSS and show you the multi-group analysis for different groups. Let me open the SPSS file. So SPSS is going to open. Now we have the SPSS import from the CSV. So the folder, So this is the data set. Now, if you click OK, you can open the data set. So that big group and small group belong to which category? So this is my segmentation, and I give the value that one means the large group, and the two means the small group. And okay, and now I'm going to do the cross tabulation. So I'm going to do for the three layer cross tabulation. Let me take segment one here, and the age in column and gender in row. Okay. So we can see that the in a small group we have four male and two female. And however, in the okay, let's do it in another way. First, because it will we have to compare. So I am comparing in one table. Let me the okay. This is no. We have to go to the cross tab. Segment I am putting the first group, and gender I am putting in the second group. Let me check. So in a small group, we have female, and in okay, so there is not much difference. Is there any relationship with gender and the segment? I can also apply chi-square test to find out whether the relationship is significant or not. And you can see that there is no relationship between the gender and the segment. So same way I can check and okay. So no significant difference I found. Significant group is association is observed between the two. So in this way, we can also check the unobserved group heterogeneity. Now I am showing you how to do the t-test and the ANOVA test, like how to compare the mean of the groups. We are having these summation scores of the variables, and we are going to use these scores for comparing the groups. So I have two groups, age and gender. So let me try the independent sample t-test. We take the test variables here, and group, suppose I want to compare the gender. Is given here, and we have to check whether all the means are different or not. Like in case of male is high. Okay, the male mean is slightly higher side. So we can see the male are slightly higher side, and if you see the p-value, the group mean is found to be significant in case of UB, usage behavior. In case of usage behavior, the mean is found to be significant. However, in all other cases, the mean is not found to be significant. So mean is not found to be significant in other cases. So it means the mean is different for the different groups. Okay. And if we check out the variance, in variance, the variance is equal only in this case, habits, the variation of the male and female are found to be different. The variations are found to be different in case of males and females, but the mean is found to be different in only in case of the UB. So similar exercise we can do for the age. Like if we go to the compare means ANOVA, because we are applying ANOVA. Why? Because age is having three categories. So if any variable is having three or more than three categories, we can apply the ANOVA. Okay. So this is the variable and the factor. Options, we are going to compare the descriptives, homogeneity test, means plot, and in post test, we have Tukey and so now we have to check the F test first. F test first. So all the F tests are found to be more than 0.05. So it means the significance is not there. It means all the variables are significantly same, or no, no, they are same, not significantly same. They are same for all the age groups. So mean of all the age group are exactly same. The mean of all the groups are exactly same. So there is no difference found. However, in case of the Levin test, the variance also found to be same, but different in the case habit, and the difference in this this is the case of trimmed mean that we have to not check because in case of performance expectancy, the significant is found. No difference significant is found. Yeah, difference is also found in case of intentions. Variance of the groups. Multi-group analysis, the PLS and query. If you have any query, please ask so that I can demonstrate in detail. Now, because all topics are very easy to understand.
Good morning, sir. If the number of variables are increased, so is there any ideal number we should take, or we can take a higher number also?
Number of what?
Number of variables,
Variables.
yeah, yeah. Does it
So
create
in case
problem
of
if we take a huge number of variables and we should cut down? And is there any ideal number?
no, actually, we have to take the score of the total construct. Actually, in the questionnaire, normally we have 50 variables, 60 variables,
Okay,
but number of constructs is only 7 and 8.
okay,
You may not have the constructs, number of constructs more than 7 or 8. We never apply the comparison between the variables. We always compare the construct scores, not the variables. I hope you get it.
yes.
Okay. So as you can ask any question to me, there is not a problem to any area, to any research.
I have one question.
Sir.
So actually, if we talk about the reliability or validity, we can calculate the reliability through that Cronbach alpha through SPSS also. Then as you demonstrated through this PLS also. So is there any kind of difference between,
No difference.
no difference?
Because I have checked many times. So no difference found between the Cronbach alpha of the PLS as well as SPSS. Both are exactly same.
And same is with the validity, convergent validity of and as well as PLS.
Yeah, formula is actually same because the formula, the actually the composite liability and average variance expected, it is calculated from the beta,
Mhm.
and beta is maybe different in PLS and MOS because in MOS they are applying the maximum likelihood estimation method to calculate
Yeah.
with the help of PLS, partial least square method. So if beta is different, the CR and AV may be.
Sure.
But Cronbach alpha depends upon two things. Number one, what is number of variables? Suppose you are calculating the Cronbach alpha of 5 items, 7 items, so number of item same in both the softwares. And second is the average correlation. Average correlation is also same in both the software. So Cronbach alpha wise there is no difference, but CR and AV may be different.
So is there a significant difference or a minor
No,
difference?
minor difference.
Question from anyone? So I don't think they have any question. You can
Sir, good
proceed.
morning, sir.
Yeah, good
Yeah.
morning, sir.
Am I audible, sir?
Yes, sir.
Sir, in the PLS, that they compare beta coefficients. So if the beta value is more than to other, we say that suppose beta is 0.35, another coefficient is the 0.25. Then what we on the part for that?
Okay, sir. So let me answer you in different way. Suppose calorie intake is the input variable. In weight is the output variable. And we know that if we take more calories, the more it is a normal relationship. Now we want to see whether this relationship is different between young people and those of us are very familiar with this concept. So you can say that the relationship is high in case of young people. Sorry, relationship is weak in case of young people because even if they take more calorie, the weight will not increase. But the in case of old people, bound to be high because if you consume your weight will definitely increase, right? Now there are two. Number one, whether this difference is significant or not. Whether the difference of the relationship between the two variables is different. Difference is significant. Now this which is not answered by the software is that why the difference is significant. Now you have to find out the reason from the theory, and theory say that because of the metabolism the difference is found to be significant. Young people have more metabolism and the old people have weak metabolism, so difference lies because
So is it not, sir, is it not cause about the exercise? Because young people are going to the exercise more than the old the picture or not?
yes sir, actually is one exercise. So old people don't do much exercise and young people do much exercise. So this may be the second reason. Actually, sir, I am telling you, researcher इस दुनिया में दो तरह, एक वो जो दिमाग से रिसर्च करते हैं, एक वो जो दिमाग से. I hope you are getting me.
Yes, sir.
जो पहली जो कैटेगरी है ना, जो दिमाग से रिसर्च करते हैं और जो दिमाग से रिसर्च नहीं करते, तो उनमें एक ही डिफरेंस होता है बस.
सर प्रॉब्लम क्या होता है सर? Just suppose I'm belonging from the Calcutta region.
Yeah.
At first, I assume that result will come. So, but when the result will come different way, then I am afraid. So, whether it will be accepted or not, this is the problem for that.
Okay, I'm telling you that. So, whatever reasons you are giving to the explanation, you must have some literature support for that. If you have literature support for the reasoning, it must be accepted. Otherwise, it is not accepted because you cannot create reason on your feelings. Reason is justified the theory. So मैंने आपसे कहा ना कि जो लोग दिमाग से रिसर्च करते हैं उनको बैकग्राउंड पे सब होती है और वो हर चीज को थ्योरी से रिलेट करते हैं. Software, what software is telling you? Software is telling you that there is a difference between group number 1 and group number 2. Software will never tell you that why the reason of difference, what is the reason of difference, right? So that you have to create from your mind, your understanding of the theory. So if you have understanding of the theory, then you can relate it, you can you can explain very easily. But if you don't you don't have the command over the theory, then you cannot relate it. Software क्या होता है कि software is a monotonous work. Software will do only the result. Now there are many people who just take the result and explain in the paper. So उसको मैं कहता हूँ कि वो लोग अपना दिमाग नहीं लगाते, वो लोग दिमाग से रिसर्च नहीं करते हैं, वो सॉफ्टवेयर ने जो दे दिया पेस्ट कर दिया. The second category who go in the depth of the theory and find required.
Thank you, sir.
सर इसीलिए लोग कहते हैं ना
Yeah.
कि statistics is not research. Statistics is describing the results.
That
It is research. तो
Yeah.
यदि सिर्फ डेटा देते हैं वो रिसर्च नहीं होता है, पेपर इसलिए उनका पब्लिश नहीं होता है.
Yes, sir. Very true, sir. Very true.
And you have to interpret it.
Yeah.
That's it. That is the reason why a researcher cannot be statistician as well as researcher both. You have to go to a sharp statistician to get the data right.
Yeah.
कि आप सब कुछ करेंगे तो it is not possible, but you should know how to do it. That's right. But sharper interpretation your domain. And ये
Yeah.
सॉफ्टवेयर वही है सर. आप सोचेंगे कि ये सिर्फ टेबल लाइए आपका पेपर पब्लिश होगा, ऐसे नहीं होता है सर.
नहीं होता सर.
Based on my own experience, who has published a lot of papers internationally, Ajay Kumar knows me well. So,
Yes, sir.
this is my experience. So यही difference होता है. You should know this how to apply, but you have to take the help of a good physician if you want to get published in a good journal. ये है मेरा opinion. As you rightly said, Ajay Kumar ji, nice to see you in this platform.
Yes, sir. सर इसीलिए मैं कहता हूँ कि दिमाग रिसर्च दो तरह की होती है, दिमाग से और दिमाग के.
एकदम सही बोला सर आपने.
Sir, excuse me. I have another question, very layman question.
Yeah.
That I have the dependent variable and independent variable. And without ACM, I am relating for this thing. And is it possible? Suppose through the literature review, I've given some relationship about to the independent to dependent and dependent to another dependent. Is it acceptable or not without ACM? As for example, I have push variable and pool variable in tourism. It is related to the travel planning. That means push variable and pool variable, both independent variable, and I will try to relate to the travel planning, whether it is related or not. Push variable is directly related to the travel planning, and pool variable related to the directly relation to the planning, travel planning. Is it acceptable without ACM?
No, sir. Actually, I'm telling you, if you don't apply SEM, then you have to apply simultaneous equations. And believe me, simultaneous equations is a very complicated concept. So you may go to second stage, least square, or any other method. But your work very easy. I'm telling you, because SAM will incorporate the mediation effect, the moderation effect in a single diagram, and your results are better than any other case.
Definitely, sir. So PLS is the paid software or free software, sir?
So PLS is a paid software, but it is not very not a very costly one. So hardly I think they are selling it for per month basis, and $22 per month. I think €22 per month. So whenever or 1 month is trial version is free. So they always give you 1 month trial version free, and if your sample size is less than 100, it is absolutely free.
Thank you, sir.
Any other query?
I don't think they have any kind of queries.
Yeah, actually, I do not know what is the level of the cancer. The topic which I discussed here is quite technical.
Yeah, it's technical, so we can
It
understand.
is technical topic, and so it is assumed that some basic knowledge is there. But if the participants are at beginner level, so they may, I don't know whether they understood it or not.
They should just actually say ask if they haven't understood. They should have interacted actually.
Yeah, but exposure is important.
Yeah,
Yeah,
we can understand. Until unless we start just analyzing things with data, we will not be able to understand. That's the
yes.
fact actually. So, do we have Swati, Dr. Swati? I don't think. So, sir, are we done for the day?
Yeah, actually, I normally keep 15 to 20 minutes for discussion. If discussion is not there, then
So, you want to into say AMS versus PLS? The question is
the
not clear.
yeah, MOS is a covariance-based software, and it is used to examine the theory, and your sample size is required to be large. But PLS is a software which is requiring low sample size, and even if you theory is not there, you are establishing or developing. So you can develop the theory by adding the predictive relevance concept in the theory. So PLS is used when you have formative construct, reflective construct both, and MOS is used when you are having only reflective construct. So that is one difference that between Smart and PLS, Smart PLS and the MOS software.
So, but one thing which I have experienced actually with this data, the number of actually responses. So, whatever methods you use, the reviewers actually just point out a number of actually respondents you have taken. Because I personally have faced a lot of reviews related to the number of respondents. Because we in India are facing a lot of problem in collecting data.
Yeah.
And in COVID-19 situation when we are not able to just reach out to people, so
Yes.
we face a lot of problem in collecting data, and then uh, collecting say 200 data it's become very difficult.
Data collection is requires a lot of skills.
So even say if we talk, if we reach out to the respondents through mobile phones, say WhatsApp or say even emails, they don't respond.
Yeah.
But we get a lot of say reviews that your say responses are too less. For example, even if you have 200 say respondents, they say that data set is not that much proper. So that if we go with that PLS thing and then our data set is less, for example, we have say 150 respondents. So the reviewers of say
250
high.
is sufficient for PLS, and I'm telling you, but you have to show some additional features, additional outputs along with the normal output. Like you have to indicate the Q square, F square, square, then the predictive relevance. So some extra output is required.
Okay, fine.
So please take the question from Srivastava, sir.
No, he's not.
Sir, good morning again, sir. Uh, Hello. Am I
Hello.
audible,
Yes,
sir?
sir. Yes, sir. Yes, sir.
Sometimes it is the parametric or non-parametric, depend upon to the data set. Whether
Mhm.
it a normality depends upon to the or histogram or cosmography studies. So in this particular case, we are given to the parametric test. But in the second option, if it is data is non-normality, we are going to non-parametric test. But sometimes we are concerned about this, as for example, correlation and also the chi-square. In this particular case, data is not normality. I would like to take a normality test. What to do at that moment? We're going to the again to the data
No,
set
no, no.
to
Actually,
for to collect the data.
non-parametric come from two sources. Number one, if your data sample size is very large, and second, if you are only on the nominal only on metric, but non-normal, if normal. So like bootstrapping procedures. So we are having the solution of the non-normality, non-parametric by applying some advanced technique like simulation or bootstrapping in the data. So that is perfectly fine because in PLS we are having the facility of applying the bootstrapping method. But if your data is very small and you are working only on the categorical variables, nominal variables, then it is non-parametric and limited to the sample size. So generalization may not be there because in chi-square we are only finding out the relationship between the nominal variables. Correlation is parametric. Why? Because we are analyzing the correlation between the scale variables. So that is a difference.
Thank you.
So there are some questions on the chat box.
Okay, the minimum sample size required for PLS is largest construct multiplied by 100. So 10, sorry. Suppose your largest construct is having 7 items, so 70 is enough. Minimum 70 is required. And the one question is that can we perform MGA using MOS? Yes, we can do MGA using MOS. That perfectly we can do. But if you have 3 variables, then there is a problem. Otherwise, in 2 cases, it is very easy. If you have 2 variables, 2 groups, then MGA is quite possible.
I think there is no other say query. So, okay, Anita Verma, again, your question is not clear. Reflective and say formative constructs.
Actually, the reflective construct and formative constructs are slightly big topic, so can't be defined in one sentence.
No,
So,
we had a session related to reflective and formative constructs.
yeah.
Okay, fine. I think there is no other query. So it was a very nice session, Dr. Ajay, and then we are really thankful to you as an organizer. And then I hope that the participants have got something because we can understand these technical sessions. Until unless we have the data set, we are working on with you actually with the resource person. It becomes a bit say technical for us, but again we are really thankful to you, just you just accepted our invitation, and I hope we'll be having the next session of yours in the advanced thing, and then
Yes, sir.
we hope we'll be having the same thing again, sir. We are very thankful to you.
Thank you, sir.
Take care. So participants, we'll be having our next session at 11 only, so please don't leave.
Okay, sir, I am leaving.
Yeah, thank you, sir.
Thank you.